project data analytics community, I think I've been involved in it right from the first project hack a couple of years ago. And it's definitely one of my favorite communities because what you guys have done with this is fantastic around building an industry specific analytics capability within the community. And I think that's where the real potential and power comes. You can do lots of courses and learning and generic stuff with tools like Power BI and Python and Excel even, but actually it's all about the application to a sector or an industry, because that's where you get real value from it. So I'm really happy with that. And I think that the hackathons are again a great way to practice this. So if you haven't attended hackathons before, make sure you do. And looking forward to when they come back to be face to face again. Hopefully, we can because that's also where the real buzz is as well. Yeah. So yeah, actually, I just thought I've got a poster up in a little certificate up in my wall next to my MCT one. It's got the Project Hack. It says Project Hack 1. So yeah, Project Hack Hackathon winner 1. So actually, I won the first hackathon. I was in the winning team of the first hackathon. I was just looking at that actually. Yeah, I'd show it as a camera, but I've got a background on. So absolutely, the hackathons are great. Definitely worth getting involved in, and this is a really good community. So absolutely well done. That's true actually. I mean, there are definitely benefits of doing this virtually as well, right? So people like Fernando can join because he's 10,000 kilometers too far, but I think you need to come to the UK, Fernando, as well. You can all that money you've saved during lockdown, maybe you can get a flight over. So what we're going to cover today is just a little bit of background on me. So I work at Avanade. So we're a joint venture between Microsoft and Accenture. So we're basically the Microsoft arm of Accenture. So decent sized corporate that focuses on Microsoft technology. So everything to do with kind of data analytics and also broader. So things like dynamics, security, infrastructure, apps. So the whole suite. I'm an MVP, which means I'm one of the community leaders recognized by Microsoft for doing things in the community. So this is a great example of community to say I'm a big fan of the data analytics community. I'm also an accountant by background, so I'm actually not from a kind of traditional BI background. I actually trained as an accountant at Deloitte and then worked in financial services for a while. And then there's two main communities that I run. So one is called LearnDataInsights.com. It's quizzes and courses that we're building for people who want to study for Microsoft exams, so things like the DA100, and then Power Platform Finance, where I'm trying to build a sectors-focused community. Haven't been anywhere near successful as you guys yet in building it out, but it's getting there. Where we're doing content around the finance sector, so for any industry, the finance function and how that can be more efficient using Power Platform tools. So powerplatformfinance.com. We ran about 20 webinars last year, so it's worth checking those out if you're interested in space. We covered everything from Dynamics, Power Apps, Power Automate, but also all the add-ins and some things like that for the finance space. And there's a lot of crossover between finance and project data analytics. And we've actually seen some people here in finance as well. So yeah, that should be quite an interesting one for you. So what we're going to cover today is kind of four main areas. So this is around how we go from just some data that we need to analyze to how we then design a solution. And I've included some templates then the link, and this is all really for what things you can do in like a hackathon as well. So a lot of this is, rather than just trying to put data into Power BI or into a tool and see where it's interesting, actually try to understand what your audience are looking for and then base your solution around that. And then hopefully that will get the right kind of adoption within the organization or within the project that you're working on. So so we've got four main steps. So know your audience. We're going to look at completing a scoping template, looking at the data granularity and scope, and then conceptually designing a data model. So yeah, this is what I was just saying. Where do you need to start with building a Power BI report? You know, do you look at doing some data analysis? Do you look at capturing requirements, designing your architecture? And how do you actually go from data to the visualization? And the place to start is not necessarily just chucking data in and putting some graphs in and saying, okay, yeah, this looks interesting. We can do a line chart here because we've got some data over time. We can do a bar chart here, but actually really thinking about the questions that you want to answer. So this is what we're going to really look at today. And a good place to start with that is this idea of user stories. So oh, brilliant. So yeah, so a user story is quite a common concept in agile development. So this is just a definition from Wikipedia. It's an informal natural language description of one or more features of a software system, often written from the perspective of an end user or user of the system. So the idea is this is a way for you to capture requirements from your users. So when you work with agile, this is quite common for you to be able to capture the requirements. Then you can build features around the user story. So here your users are the end users of the report. So the format of a user story is to say, as user X, I want to do Y so that I can achieve Z. And this end bit is really important because, especially for something like reporting, it's the so what. It's the why do you want to do this? What difference are you going to be able to make with that that data, with that insight? So, you know, if it's showing you where there's slippages in your project, you know, you have something actionable that you can then do to achieve that. If you understand the reasons for those slippages, you can go and increase staffing or move staff around, or, you know, increase budget in particular areas. So that's how you can capture a user story, to say, as the project manager or as someone responsible for this aspect, I want to understand the impact of this, or I want to be able to know what's going on in this particular area so that I can do something about it. So let's apply this then to this scenario. And let me show you first what we're talking about. So I'm going to bring up the data that we're working with. Again, this data is just an Excel file. It's there in the resources that I've put a link to, a zip file. So what we have here is procurement process for a construction project. So this is dummy data, but it's based on a real life example. So we've got data for July and August in separate tabs. And what we have here is then for each work package. So the work package here represents a bit of work that needs to be done, or a set of materials essentially that need to be procured, and resources to be procured for a particular bit of work. So each bit of that procurement process goes through a series of stages, as many of you will be familiar with, about design documents. So when did we plan to complete the design documents for that work package? When was it actually completed? The request for information, the RFP, request for proposal, that was put out, the bid return, technical evaluation, commercial evaluation, plans and actual. So all of these dates, request for quotation, and then we've got approved forecast, RFT, purchase order, and then once we've issued the actual purchase order, that's when we can then get the materials on site once we've done that. So all of these stages in the procurement process. I'd be interested to hear if people have followed this kind of process as well with some of the construction projects, and if this looks familiar. And then we've got two columns at the end. So the date that this is required on site, so the ROS date that we need. So this is the date that we need the materials on site in order to not delay the project. And then this is the actual ETA of when it's due. So it might be early, it might be on time, or it might be late. So where it's late, we've got slippage in that particular work package, and we're tracking this at each individual work package level. So this is for all the ones in July. This is our status of all the work packages in July. This is the status of all of them in August for all the dates. And then we've got these work packages also contain the codes for the type of activity. So if we've got stages here, So it's activities here. So BS, we've got, oh great, yeah, very normal, good. So we've got concrete base, brickwork, cabling. So EC there relates to that. BS relates to the base. And then we've also got all these different stages. So these different stages along here, we've got the stages here, and then we've got the person responsible for them. And we've also put them in the order. So again, having an order column is actually quite useful and important for when you have your data. So data like this, you know, it's worth just creating this quickly in Excel or even directly in Power BI or something, just so you have those that information that you can then use, that the metadata helper tables, if you like, with things like an order column. So hopefully this kind of process looks a bit familiar to you, and as you'll probably appreciate, this is not the easiest data to work with because you've just got a whole bunch of dates. It's not very clear how you would need to structure the data like this to be able to do some analysis of it in Power BI. And if you just chucked all this data into Power BI, you'd probably find yourself in a bit of a muddle quite quickly in terms of not knowing how to do the calculations or not knowing what to show. So, I mean, if you guys have any ideas about how you might approach this, again, feel free to put something in the chat or even come off and you know, share some thoughts. It's absolutely keen for this to be interactive. Digging. Okay. So, right. So then let's get back to, okay, so what would we do with this data? So we've got two main users that we've identified here. So we've got Mark, who's the project delivery lead, and Jason, who's the operations lead. So for Mark, we're saying he really wants to be able to identify slippages and project delays. So, you know, really we're focusing on that float, which is the difference between the ETA and the required on-site date. That's really what Mark is interested in, so that he can mitigate the impact of these. So he can mitigate the impact of slippages and delays on project delivery. We've then got Jason, who's the operations lead, and he's also interested, obviously, in these as well. But his specific area is to look at bottlenecks across the project stages. So to look at, you know, generally, how is, you know, are we doing the design, the RFP, the RFIs? Are we doing those on time? Are vendors taking longer to respond to these things than they should? Where are the bottlenecks in those stages? So he's more interested in some of that vertical, in you know, those columns rather than necessarily on their ETA versus ROS. And also, and just so and he's interested in that so that he could work with those contractors responsible to resolve those bottlenecks. Hopefully that will make sense. Any questions? Obviously, yeah, please feel free to ask in chat. I've got the chat open there. You could use a milestone trend chart. Yeah, actually, if you've got an example of that, actually, if you could put a screenshot of that, if you have an example, I'd be interested to see how you track milestones in that, because it's not actually, so it's one of those things I've actually had to do in a project as well, and it's not. We ended up building a custom visual, I think, for it to show milestone trends, because it's not the easiest thing to just show out of the box. So if you have some good examples of that, that'd be good to see. Decide what the most important problem to manage is and what dates are relevant to providing that. Yeah, absolutely. So yeah, that's what we're going to have a look at now as well. What kind of calculations or metrics we need to decide on. So one of the tools that I've provided for you to be able to do that, oh brilliant, we've got there a metrics chart. I'll bring that up in here just so people can see it. Yeah, this looks quite interesting. Is that a custom visual then? Well, that's not Power BI, is it, or is it? Yeah, I'd be interested to hear what that is. Okay, I'll check that out. So yeah, absolutely, those kind of things we need to, not Power BI. Ah, what a shame, Martin. Okay, well, yeah, I mean, if you want to do something like that in Power BI, it's possible. So actually, with Power BI, what would be, and I might actually do this because I want an opportunity to learn this, but Power BI have just recently come out with, they've got an open source tool where you could build custom visuals without code. So traditionally, your way to build custom visuals in Power BI has been using R, Python, or JavaScript. But they've now there's also been a third, well, it's built by Microsoft Research, but there's been an external tool called Charticulator. I'll just put the name of it in the chat. And they've actually brought that into Power BI now. So now you can build custom visuals, maybe like that actually, inside Power BI. And you don't have to code them, you can do them within as a custom visual itself, or as a visual itself. So something like that would be quite interesting. But today we're just going to look at using some of the standard visuals. And so digressing there a little bit, one of the tools that I provided a template for is the scoping template. It's a very, very high level scoping template. So I'll bring up an example. So yep, it's blank, but it's not actually blank. It's a very high level Word document. So it's kind of a table for each area. So here we've got two main areas, and these could be pages in a report, for example. So we identify for each one who's the audience. So here we're saying this delay analysis report page or area is aimed at Mark. And Mark really wants to know. So now we're defining the problem statements. What is Mark specifically really interested in? What is his actual problem statement? So this is really the user story that's expressed as a problem statement. So he wants to know what has slipped compared to the previous period and where the slippage occurred so that it can be fixed before the impact of schedule becomes too large. And he wants to understand which work packages are currently delayed and by how much to understand the impact on schedule and cost. And then from there, and obviously this is through a conversation with Mark, we look at the questions, the key questions that he has that he wants to answer. So, how many work packages are delayed compared to the previous period? How many at each stage? Which work packages have become delayed within the last month? And this kind of thing will be really interesting to ensure that the report becomes relevant, because there might be some work packages that have been delayed for 6 months, 9 months, and we can't necessarily do anything about those. We know about them, we're aware of them, but actually which work packages are now delayed that weren't previously delayed? So which ones were delayed in August that weren't delayed in July? At what stage have they become delayed at? And how delayed overall are the packages at each stage? So then once we have those questions, we can think about what are the KPIs and measures that would help us to answer those. So these are the things we need to think about that we want to define. The calculations essentially that we want to define. So the number of work packages, the number of work packages delayed, the number which become delayed, the value of the work packages delayed, and the total delay in days. So those are the kind of key measures that would help to answer those questions. And then what would we want to view and filter those by? So by stage, activity type, time, and delay category. So we're probably interested, if we just did an average, that could be useful. So if we did the average delay and looked at that, okay, yes, that might be useful, average delay by stage, but actually that might also hide some of the things that we want to. So we can actually say we've got 1 work package or 3 work packages that are delayed by more than 6 months or more than 12 months, then we know those are ones we can go in and focus on. So the idea of data visualization is to really give people the answers to their questions as quickly as possible to avoid cognitive load. So that's what we really want to do. And then very high level, what are the data sources that would help us to answer those? So, we don't need to go into the detail here, but we're just saying it's the list of work packages, plans actual for each stage, and the ETA was date for each work package. And this is just kind of a sense check to make sure that we've got the kind of data that we need, very high level, to be able to answer these. As I say, this is a very high level exercise. It's kind of just things that we can capture or requirements out of the workshop sessions and the user stories that we're capturing for our reporting. And we've done a similar thing for the stage analysis. So where we're looking at bottlenecks and how it's comparing to the number that we have planned in each stage. And what I'll do now then is just show you the report, and I'll tie it back to some of these questions. So if we now just open that up. Where's that? Which window is that loading on? There you go.
We have a question, Rishi.
Yeah, sure.
A question from the audience. Could you explain a bit more about cognitive load, please, and what would add to that?
Yeah, absolutely. So actually, I'll show it here now with this example. So that's good. Well-timed question. Excellent. So I start actually, so the first page of the report is actually the scoping template. And the reason I've put that on there is so that when someone's coming to this report, even if they haven't necessarily been involved in the initial scoping, they know what questions this report is trying to answer. So they know, what the data source is, what the questions it's trying to answer, and hopefully this resonates with them. So you've built some credibility at that stage as context. And the other things that are useful to include on a kind of cover sheet are, when the data was last updated. I didn't include that here because it's not actually been updated. And what the data source is. So some ideas around that, around what the report is, and maybe some instruction on how to use it. So who built it, where it's from. So some of that information is useful context to people coming into it. The next one that we have is this delay analysis. So as I was saying, the idea of cognitive load is that it's the amount of work you need to do to be able to understand what the report is telling you. So examples of things that increase cognitive load are complex visuals. So having visuals which might be really fancy and lots of information on them, but they'll take a while for people to understand. Things like bar charts and line charts, people are very used to. It's very clear what it is. They're used to doing that. Another thing is color. So where you've got rainbow charts with lots and lots of different colors in them, and you've got sliced by 10 different attribute values, and it makes it very hard for you to decipher those. So even things like pie charts, for example, that's why pie charts have a bad reputation in the data visualization world. It's because actually it makes it it's very hard for the human eye to be able to distinguish how big relatively those are. Actually, the bar chart is much easier way to do it, and it shows one of the same things. So the idea is to make this as easy as possible for people to understand what the report is telling them. So things like having a series of metrics at the top or somewhere like that is a good way to answer that question. And the way to think about this is, like someone's marking an exam. So the marker for your exam, you want to make it as simple as possible for them to just go through. They've got thousands of exams to mark. They need to be able to just go through and tick off and say, yep, I can see evidence of this. I can see this. They fill the criteria. Make it as easy for them as possible because they're as lazy. As you assume that they're lazy. And it's a very similar thing for data visualization. So we want to, this is why we identify the key questions, because then we know how to reduce cognitive load, right? If you don't know what questions you're trying to answer, it's very hard to know what you need to do. So our first one was how many work packages are delayed compared to the previous period, how many at each stage. And that's what we've got here. How many are delayed? 136 this month, 131 last month, so 5 are now delayed. And that's the value of the work packages and the total days. And then we can see at what stages there are. So which ones have become delayed by completed stage, by delay time category. So a decrease in the float, which is bad. And the work package is currently delayed by last completed stage. So we can see what stages there are, the ones which have become delayed and the ones which are currently delayed. So we can see that 125, we can see most of these delays is at the issue purchase order stage, so the last stage actually. And then we can see some details for these here. So the other thing then to think about is to say, okay, well, where's someone going to go from here? So the idea is to think about some of the interactions between your visuals. So they can say, that's interesting, I want to have a look at these work packages which have become delayed. So then they can focus on those and they can see all the ones that are at the issue purchase stage. Or they can look at those that are 1 month late, 3 months late. So they can really focus in and hone in on some of those. So the ones that have got 1 to 3 months float decrease, they can see what those are and see the details of them, the last stage, the activities, and then where to. And obviously you can see here, I think we've got these. Yeah, we can see these at the different stages as well. So I'm not sure if all the cross filtering is working on this actually, looking at this, but the idea is that you can have the cross filtering where they can select on a particular bar and then see some details or drill down into details. And there's lots of ways you can do that. You can have hover over tooltips. You can drill through, so you can set up drill through, so you can go into detail, and maybe you have the table as a drill through page. You can also have bookmarks, little buttons, which will change the layouts, change the visuals that are shown there. But that's the idea behind these. So you have these questions, and then you have the data visualizations, which helps you to answer those. And yeah, okay, so yeah, I can see a question here. So if presenting this to a novice, what is the best way to approach this without bamboozling with the data and reports? So you saying to how to present the visuals. So from the data visualization, I mean, it's really the same as you want to do for everyone. You know, you want to keep it simple, unless you've got a particularly sophisticated audience who very used to, you know, chord charts or some fancy data visualization types. If that's something that's really common and you've been using it for a long time, then perhaps. But otherwise, stick with some of the basic visuals, or you know, keep things very simple in terms of bar charts, line charts. Yeah, the summary page. Yeah, so try and think about the key messages and think about some key KPIs. So generally, you're either going to show a couple of KPIs or one KPI even by different attributes, or you're going to show a particular attribute and show that under different KPIs, for example. So the stage analysis is switched slightly around, because here what we're showing is we're showing then the number of work packages, and we're comparing the actual and planned dates. So we're showing by stage, we're showing the number of work packages that for that stage which were actually completed versus the number that were planned. So again, what's really important is not just to show numbers, but to show context as well, right? So just showing the number and saying we've got a delay of 200 days, or we've got you know, this many work packages which are delayed or outstanding. I mean, for you know, we need to know whether that's good or bad. You know, is that given the size of the project, given what we'd expect? So you know, we could do it, but rather than looking at just how many, we can look at actual versus planned. So here, then this is where we've got them in the S curves, but also here for the context. So we're using here a bullet chart. So it's like a bar chart, but here we can actually see the solid lines represent the number planned. So here we can look at how many for each stage. We can see that they're all kind of behind. And then we've got the average delay. And saying here, then we've also got the delay category, because the averages might hide some of these things. So actually we can then hone in on not just the average by stage, but also how many work packages are more than a year late or up to 3 months late. And then we've got some standard visualizations to say, actually, you know, what is the actual planned, cumulative actual planned. So the S curve type graph, which is just a line chart with a cumulative DAX measure. And then how many have we got planned and actual by week. So then we could start to see, if we look at particular work packages at particular stages, or we look at particular work packages which have been delayed, we can then see when those delays were occurring. So we can see week by week, how many did we actually plan to complete actual in terms of all of the stages versus planned. And then if we filter down, and again, this is why it's important to then look at particular cross highlighting. So now we want to focus on issue RFP. We can see we plan to complete the issue RFP process for one, and we actually completed. We plan to complete two. Sorry, we actually completed one. We plan to complete 3. We actually completed 2. So this is now then giving us the details for what those are. And again, we can build in some drill through or hover over tooltips that we can then say, I want to hone in what those 2 are. So yeah, absolutely. That's hopefully that answers the question as well around kind of cognitive load and how to present some of the data. But really, to be able to know what to present here, it really does come down to some of these business questions that we want to answer. So have you got any other, did I miss any questions there, Yoshi, or?
No, mostly statements about what's the best way to for requirements gathering, really.
Okay, yeah.
Yeah, absolutely. The current project versus current project against benchmark. So this is what Martin's saying there is absolutely right. It's about context. It's not just about presenting numbers. It's about giving people the ability to evaluate that and say whether that number is good or bad, depending on the context of the project. So we did know your audience, and then the second one was kind of scoping template. So I could have gone through it here rather than in the Word document, but that's then what we were looking at. So problem statement, key questions, KPIs, measures, and then what would you view and filter those by, and what are the data sources that would help you to answer those. And the same with those. Now we've done some very high level metrics here. Sometimes what you might need to do is define the calculations for these. So, sometimes they might be very obvious, but actually, what do you mean by work packages delayed? How is someone going to be able to calculate that? And sometimes you actually need to get these signed off before you start to really build a report so that everyone's clear on what those are. So I'll provide another template in that zip file, which is the metrics tracking template. And this then allows you to, again, these are templates, feel free to completely change them and suit them for your own purposes. They're just examples that I've used in the past. So you have all the metrics here, and then for the area, so this is coming from the scoping template. This is also, who the user is for that, what the user story is for that. So I've used the user story rather than the problem statement here because it's relating specifically a little bit more to the metric. And then what's the definition of that metric? So an English language definition. So we're saying the number of work packages which are delayed with an original scheduled end date within the last 30 days. So delayed in the last month. And then what is the formula? And again, this doesn't need to be a DAX formula or anything like that, just English or using Excel formulas type language. So distinct count of work package ID, where float is less than 0. So a negative float, which indicates a delay, and original end date within the last 30 days. So now then we've got this calculation. We know how to calculate that. So that's signed off. We can go in and build that in DAX. That's actually a relatively easy formula to build in DAX. But if you just said, I just want to know the work packages delayed in last month, there might be a bit of thinking about one of those. What's the how do you define that? How do you calculate that? What's the format you want of these? So is it a number? Is it decimal, percentage? What's the data source for this? So is it coming from a data system? And who's the owner of that? So Martin Paver maybe here is our data owner for the procurement system. And so we have someone who owns that data. What's the frequency of update? And then we might have some other things around these metrics like security. So for example, one of the things you can do in Power BI is set up row level security. So two people could be looking at exactly the same report, but we'll see different data depending on their permissions. Or we might want to restrict the report to certain people. So we're saying here, actually, only the delivery leads can see this data, this metric, and things like alerts. So with Power BI, you would tend to do this typically, I guess, for a dashboard. That's one of the main reasons you might use a dashboard over a report. So just to clarify, what you build in Power BI Desktop is not a dashboard, it's actually called a report because each of those pages and you have visuals on there and it relates to a particular data model. The idea is then if you've got one report from finance, one from HR, and you want to take one visual from the finance one visual from the HR one and put it on an overall single pane of glass, that's what your dashboard is. So you can do that in a Power BI service. Once you do that, you can also then set up alerts. So you can say, I want to be notified if this happens, and you can actually trigger any kind of workflow on those because you can pick them up in Power Automate. So if we do have something like that, we can capture it here as well. And then this helps to shape our requirements on how we want to work with this going forward. So once we've completed the kind of scoping, any other questions we got, or all good? Thank you, Martin. If you filled in a template, you have to keep it up to date. Yeah, I mean, so I think the best place for the definitions to live is actually within the Power BI report, and I'll just open that up. And I've seen some good solutions to this, but I mean, to be fair, most Power BI reports I see that the data models are not well documented enough. So, you know, rather than just living in an Excel spreadsheet that doesn't get updated, in here, if you go into, I always forget where it is actually. If you go into here, so you've got the measure definition here. Here's where you can actually enter a description. So this is the title that is shown on the cover sheet. So this is really important as well for when you're doing things like building shared data sets. So are you building data models that people can then just go and build reports on top of? And that's a good thing to do for governance. So the idea is that some people manage the data and build this logic into data models, and then lots of different reports for different auditors can be built on top of that. So that's on there. And yep, absolutely, this is just what I was getting to. As you hover over these, then they show the descriptions as you hover over them. So this is a good place for those descriptions to then live. So as you're building the measure, you know, you define the DAX measure, and then you also put that description in there as a description field. So you start to document your model within there. And then when you do, there are tools. So I've been looking at external tools. I think people look at this external tools ribbon and they go, how have you got so many? And I've used this business ops, so Power BI.tips business ops, and he's got all of these tools he's made available to everyone. But there's quite a few that have come about around documenting. And what they will do is take those descriptions, so you can then export those descriptions to Excel, or export them to somewhere else. I've actually seen one of the nicer solutions I've seen for this is actually people have them in Power Apps. So you have your descriptions, your definitions in a Power App on the intranet page on SharePoint or something, and then people can go in and search for those or kind of see the definitions. You know, maybe for some enterprise reports to go across there. Again, this starts to get into actually how can we start to build these data models, which you can build a Power BI file that has no visualizations in it. All it has is the data, and it has these measures. And then someone can just go to someone else who wants to do a visualization, doesn't have to start from scratch, doesn't have to start to go from, you know, connecting to SQL servers or connecting to systems and putting in the data, cleaning the data, and then defining these measures. Someone else has already done that work for them. They don't need to reinvent the wheel. They can just say, right, I just want to connect to a Power BI data set, and then go in and just build my visuals on top of that. So you've got a single version of the truth. So that kind of stuff is quite useful as well. Right, so once we've defined the scope, the next step is to look at the kind of data and analyze the data a little bit more. So here what we want to do is define that data granularity and the scope. So it's really, how do we make sense of the data? So now that we've got some questions we want to answer, how do we then make sense of this data and understand what we need to do? So, oh, sorry, yep, yeah, that's fine. You could use these templates, absolutely. They're there for community use. So the idea about categorizing our data is that we want to end up with tables that we define, and this is not a technical thing, this is a conceptual thing, if you like, that our tables are going to be one of two types of tables. They're going to be either a dimension table or a fact table. And the idea behind these is our dimension tables contain the business entities. So things like dates, customers, products. In this case, it might be projects, it might be work activities, it might be vendors, suppliers, contractors, work packages. All of these things could be business entities. What defines a business entity as opposed to just an attribute is that a business entity is likely to have multiple attributes. So even if you think about something like dates, which is obviously probably the most common dimension across pretty much every Power BI report, a date has a series of attributes. It has the day of the week, it has the month, the quarter, the year, the financial year or fiscal year. It has when maybe a flag to indicate whether it's a working day or not. So all of these entities have lots of attributes, and the idea is to get some of these from source. So not the same table that has your transactions or your in there, but actually a master data source for your products, for your work packages, for your vendors. That's where you want to get these from, with all of those attributes. And that's the kind of table you want to bring into your report with these business entities. So you have to say they have attributes to them, and they're the things that you slice and dice by on your report. So you'll slice by vendor name, you'll slice by work package. And actually, if you notice here, we had some kind of what are called junk dimensions. So they're kind of just attributes, kind of helpers that we do. So we had delay category as one of them, for example. And we typically have one row per value. So the idea for your date table is that you has one row per date, and your customer table would have one row per customer. And then the idea is that this then is how you then create your relationships with the fact. So our fact table is to do with the numerical data points. So your fact table really should contain just the numerical data points that captures part of the business process and the keys to the attributes. So if we're thinking about this as a sales example, and we'll have a look in a minute how to apply it to another context. But when you go in and a sales transaction occurs, it will have, there's lots of attributes that relate to that. So you might have who is the customer, how much they pay, what was the quantity, what was the price, what was the product. So then actually we say, well, actually what we have in our fact tables, we capture maybe the price and the quantity, and we can work out some revenue from there, for example. But then everything else, all those other things like the date, goes into its own date table. So you capture the dates, and then you have a date table of all the dates. You then have a table of all your customers. So the customers becomes a business entity, and you have a table of customers. And products, you have a table of all of your products. So the idea is that this fact table contains those numerical values as well as just the keys to the date key or the customer key that relates to your business entities. We should have some of these to be additive, so where you can add values together, and they should be directly relevant to the business process. So again, coming back to sales example, you might have data on, say, the salary of the salesperson who made a sale. That's not, it's a numerical data point, but it's not directly relevant to that sales transaction, right? How much they earn. So they're potentially not relevant. And initially we identified as the most transactional, the most granular level possible, because it's much easier to aggregate up in Power BI. That's what it's really designed for. So if you have individual sales transactions, you can group them by month and over time and by customer. But what you can't do is drill down into a level of detail that doesn't exist. So if you only had totals, by customer by month, that's fine. And you might want to do that if that's all you're interested in, but then know that you can't drill down into the detail of those. So say this is then calculated for given combinations of dimensions. So the idea is that your fact table will have these keys repeated multiple times, because if you make more than one sale on a given date, it will have the date repeated multiple times. If you sell to the same customer more than once, then you will have it repeated for each time you sell to that customer. So the idea is that this then allows you to create one-to-many relationships. So the one value being on your dimension and the many being on your fact. Are there any questions on that before I just go on to dates? Yeah, date is an interesting one because you might have multiple dates. So you planned, actual, and I'll show an example of that actually. So I'm just conscious I'm running out of time a little bit, but I'll show an example of that. So one of the other templates I've provided for this is a version of what's called a bus matrix, because so in Excel, you might have all of your data in a single table. And actually for Excel, that's what you need. You actually need all your data in a single table. But then even if you have or you haven't, when it gets a little bit more complicated, you might look at these and say, which facts do I have? Which numerical data points do I have by which dimensions, and which grain of dimensions? Is it by date? Is it by month? Is it by quarter or year only? So what you need to do is a way to be able to categorize your data. And let's say this is particularly for where your data gets a little bit more complicated. So I just open up the matrix for this. So the idea behind this, and this probably isn't the best example of this. I've done a very similar talk for this, but with actually it's an identical talk really, but with a finance use case as opposed to project one, and there the data set's a bit meatier. But here what I've done is put all of our numerical, and in this case they're all dates actually, but they're still dates, just numbers essentially. You can aggregate them, do max and min of them. And then we've got, so along the top, we've got all of the kind of dates or numerical data points, and then which table they're coming from. So where you've got multiple tables, you can split them out. And then down the side, we've got then the attributes that we have, all the possible attributes that we have all of these potentially by. So these can be the same table, right? A table can contain attributes as well as can contain numerical fields. So here we say date, and we say we have a date table, and we know the granularity of our date table. So actually, the good thing about a date table is we define our own date table, so we define it at the most granular level ourselves because we have those. And then do we have them all by date? So do we have all of these by date? Yep, they're all by date because they are a date. So this is a slightly simplified example, but we also have them by work package, and we have them by activities. And because we know that for each work package, we've got all of these dates by these different attributes. So we've got a table of work packages. So these are the attributes of our work packages. These are the attributes of our activities. Hopefully that makes sense. I mean, so to say, this is probably a slightly simplified example, but the idea is that we have, I've flipped it around here, but in this example, in the kind of, this is a process that's known, I didn't come up with it, it's called a bus matrix. That's part of the Kimball methodology. So that's Kimball methodology. If you Google that, yep, I think yeah, there's I'm not sure if it's the same book as Fernando's, but linked to there, but it's the same idea.
You have a question here, Rishi? Yeah. You have a question here. Why does the dimensions and facts distinction matter so much, and is an attribute the same as a dimension?
So the distinction matters so much because what you want to do, it's really about how your data model is designed. Because what you don't want to do for performance and for analysis purposes is just bring in your data and either bring it in as one flat table or just create random relationships between your tables. What you really want to be able to do is have these types of tables that you create the one-to-many relationships between. So date table links into your data, your fact table here. And the reason for that is a couple of reasons. So you don't want to have all of these date attributes in here because your fact table you should keep as skinny as possible. And I'm perfectly aware that there's many in here, so I've broken that rule already. But you want to have your fact tables as skinny as possible, and then have your attributes in a separate table and then join them up. So when you're applying filters, so when you create graphs, for example, you drag on month or year month from here, and then you drag on a value from here. And because there's a relationship between them, when Power BI is analyzing this data, it's only looking at, if there's 10 years of data, it's 3,650 values in here. You might have millions in here, but what it's doing is filtering this table and then passing the filter through to here. If you're having to filter this table, it's going to be a lot slower. It's also just much better from an understandability perspective. So, people can understand these business entities. They say, right, I want to be able to slice and dice by customer. I want to view this by this attribute, and they know where the attributes live. So it's like a house for the attributes. So from an understandability perspective, from a performance perspective, and once you start to get into writing DAX measures, if you don't have this kind of schema, it's called a star schema, your DAX will end up being very complicated, unnecessarily so, and you'll have a hard time writing DAX. You might have it's hard enough to write DAX when you've got a good data model. When you have a bad data model, it's near enough impossible. So that's kind of the reasons why I think, yeah, you just have to trust us on that one. Yeah, fact table, exactly as Fernando is saying. Fact table is long and just a few columns. So skinny as possible, and it doesn't matter if there's lots of rows. What determines your performance in Power BI, because of the way the data is compressed and held in memory, isn't actually the number of rows, it's actually the number of columns, and also the number of unique values in those columns. So where you've got IDs and things like that that have unique values in every row, those columns will take up much more space than, say, a true or false. And is a dimension table like a VLOOKUP? Yeah, but it is like a VLOOKUP, but like in Excel, you'd have to do lookups to bring all your data into one big table. You don't need to do that in Power BI. You can just create relationships between different types of tables, and that's what that's how data works best in Power BI. So it is, by the way, possible to do stuff like that still in Power BI. So you could go in and use the related function, and you can add columns. But generally, what you want to do is think about your data model. That's why the data model is so important, right? Because it really drives the type of analysis, how easy it's going to be to write your measures, determines performance. All of these things are driven by your data model. So it's really important to get that right, and that's why I'm focusing on it here. And I'm sure. I don't know if you guys look at the data models behind when you do the hackathons, but it's a good idea too. So here, this is just an idea as well. Talk about granularity. Yep, thanks, Nathan. That's the book I was referring to. Actually, that's the one I've got actually in my next to me now. Actually, that talks about the ideas of facts and dimensions. So this is just looking at aggregation. So actually, do we want to bring data in at the most granular level? I'm actually going to skip past this because we've talked about the idea of granularity, and there's some other things I want to try and get through with this. The last step and the last template I've provided here is for a template called Starnet. And really, this is for you to just define what those tables look like. And again, what we're trying to do here isn't necessarily a technical exercise, it's a design exercise. So you could do these kind of things with non-technical audiences. You might not do the bus matrix with them because that's just analysis of data. So if you're a data analyst, maybe you'll do that. But this around designing the data model is something you can do with a completely non-technical audience. The idea is that you just draw a circle. You can do it on a whiteboard if you're in person, and you put your measures in that circle. So kind of your fact table measures in there. And then you just have legs coming out of that circle that represent your dimensions, your categories. And then here you put in the attributes that you want. So the idea is this then defines what that structure looks like. And where you've got some complicated structures, this really helps to kind of design what your data models look like. So what we're saying here is our work packages. We need to have something around current, last, completed stage. So the stage needs to be then the order, the person, the procurement stage. We need to have a float delay category. So this is just a simple kind of couple of rows table that we define ourselves to say, is it, I'll show it to you. It is here. So it's the category, we define the categories, and we define the lookup. So we say the start number of days, end number of days, and I'll show you how I then created that in there. But the point was, if we didn't go through this exercise of defining that, we wouldn't know we necessarily even need this table. We might just come halfway through building our model and be like, actually, we need some way to categorize it. And we might start looking at the inbuilt functionality of Power BI and realize it's not what we want. So then we're kind of, making this exercise a lot harder. If we're doing some of this thinking up front and saying, yep, we need to know the category, then we can do that. And then we've got dates. And the difference between these lines and these circles is that these circles represent a hierarchy. So the activity is a hierarchy. So we've got different attributes that follow a particular hierarchy. And dates are obviously hierarchical as well. So the quarters feed into the months feed into the quarters feed into the years. It's a little bit roughly drawn there, sorry about that. And yeah, so that's the kind of last template. So this is basically then the blueprint of what you need to shape your data in Power BI. So let me show you. I'm not going to go into detail of this because there's quite a few technical challenges, as you can probably imagine, to come up with with this structure then to come up with a structure in Power BI. But I'll show you the query editor and we'll go through kind of what we did. So there was two kind of key fact tables that we had here. So actually, let me show you the fact tables first. So we've got probably should have split this out into fact tables, but so one fact table we had was actually the ones with our dates. So it's actually basically very similar to what we had in our raw data. I think there was a reason I brought these all in, but I don't think we needed all of these columns. And I think I might have actually just brought them in as an example and actually say, actually, we've got all of these columns, but we don't need them all. So actually, let's cut them all out. I think that's where I was going with this, because all of these columns are not actually going to be useful to everything that we're doing. But we've then got a calculated column on there to say what is the last completed stage. So actually, what's the last stage where we've got something actual? And I think that was what we really needed from here, was the last completed stage and the ROS and the ETA. And I think then we could actually have got rid of the rest of the columns. And that's a good practice, because then we don't need to bring them all in. So that's one fact table. So by date, by work package number, what is the ROS, what's the ETA, and what's the last completed stage. Yeah, and then I think I brought these in to then show the detail if we wanted to go into the detail, but the ones we're really using are these. What you should always do as well is pick the columns you want. So you can go into here and go to choose columns, and here you choose the columns. And it's really good idea to do this first, actually, if you can, right? So if you need to use these columns for a calculation, use them for calculation and then remove them. The reason is because all these columns take up extra space. As I said, I left them in here. Actually, I remember that I left them in here because I wanted to have that table that showed all the detail behind it, but they're not really being used. So actually, ideally, if we don't want to have these columns in here, we don't need to show that detail. Let's remove them. And yeah, you do everything through the UI. You don't really do things in code really in Power Query. You can do, and I have actually used a bit of code here, and I'll show you for the next fact table. But generally, you do stuff with the UI. So you delete columns essentially by unselecting them here, and then they won't be part of your data model. The other one that we had is for each work package, for each stage, what was the planned date, what was the forecast date, what was the actual date. So the idea here is that what we're doing is this work package is now repeated multiple times. So this procurement data one has one row per work package per month, actually. So it's repeated for each month, but it has one work package for each month. This one has for each stage in each work package, what's the planned date, the forecast, and the actual date. So this is really for us then to be able to then look at the variance between these, work out the delay stage by stage and the number of work packages. So then we can do a distinct count on here to be able to say the number of work packages which are delayed at this stage, this stage, this stage, and this stage. So these are our two kind of fact tables that we need. And if we look at that then just in the relationship view, we've then got our work packages. So we've got our procurement data. That's one fact table, links into date. And then we've got procurement tasks. Now, I think Russell or someone else in the chat said about actually you've got the issue where you've got multiple dates, because here we've got a date for actual and we've got a date for planned. And we actually got a date for forecast as well, though I think that was empty. So what we can do here, we've got two options. We can either create 2-day tables, a planned dates and an actual date, and then create different, use whichever one we want to show. But you wouldn't be able to do things like S-curves if you did that, because you want to show them across the same axes. So I've opted for the second option, which is basically to create two relationships, but they can't then be active because you can only have one active relationship between two tables. So what I've done, this is why these lines are dotted. So I've created a relationship, one from date to actual, one from date to planned, but they're not marked as active. I've actually marked them both as inactive and then just activated them on demand. So where I have multiple relationships, rather than having the default one, I actually tend to like just to keep them all inactive. And then in here, when we actually do, if we have a look at the measure, it uses work packages by plan date. So now we've got two different types of measures. So we've got number of work packages, and yeah, feel free to have a look at this report in detail, and feel free to ask any questions about it. I'm not saying it's necessarily work packages by actual date. Why can I not see that? Here you go, actual date and by plan date. So then we've got number of work packages, and then it has this use relationship between the date table and the plan date, whereas the actual one has use relationship between the date table and the actual date. So that's how we then utilize those inactive relationships that we set up here. That's those. Last thing I'll just show very quickly is what we then wanted to do. For example, we couldn't create a relationship between that and our table. So essentially, because we actually needed to know which one of these it fell into. UI is user interface. It just means without having to go into the code. So just using the buttons, like the GUI, which is graphical user interface. The features in Power BI that are not code at all. So it's just these kind of features. So when we have a number, so say we have a float, right? So we have a float of say 20 days or 50 days or minus 30 days, and we want to be able to categorize those. So one thing you can do in Power BI is use the default number, the default binning or grouping, where you can create, you can group and bin numbers on here. But I wanted to use my own lookup table, and so the idea behind that, then, what I had to be able to do is I couldn't create a relationship between these because I want to see which category, which bucket it falls into. So if you're familiar with Excel, it's kind of like doing a match with a 1 at the end, or VLOOKUP with true at the end, where you need to then look at which category it falls into. So I did that by, if we have a look in procurement tasks, so by using this kind of filter function, so it's actually almost like it's saying filter, right? So I've got this as a disconnected table, so I couldn't create a relationship between it. It's a disconnected table, and then I've got in here filter that table for where the start dates is less than the actual planned variance, and the actual planned variance is less than the number of end days. So where it falls within there, filter that, and it'll be one row because it'll be each day will fall under one of those categories. And then it returns those on there. So 6 months up to 1 month late. Where we don't have the dates, we just say, if we've got blanks in here, then we just say it's unknown. So that was just, again, a way to kind of get around some of those things that we can, where we can't create relationships or where we've got multiple relationships. Cool. Sorry. Yeah, I did get into a little bit of technical detail. I wasn't supposed to be a technical session, but it was kind of just going to show then how you can go from what is a really, really messy data set to a structure that kind of works around what you need to do for your analysis. And that work is quite complex. So actually that's why it's important to shape what your data is going to look like, what your data tables are going to look like, which you're going to have as your dimension tables and which is your fact tables before doing it. Because otherwise, if you just go from there, it's very hard to know how to structure this data into anything where you can do any kind of analysis on it. And the actual hard bit is shaping that data. So that's where the Power Query stuff comes in on the data modeling. Cool. Question for us, so what about unpivoting the multiple data columns to avoid need to be use relationship? Yes. So you could have actual or planned as an attribute. Yes, I think. Yeah, but the challenge is I wanted to work out the float, the variance between them. So I wanted to have the variance, actual to planned variance, and then a variance time category. I couldn't really do that if they were all just in one column and just had an attribute. So again, for things like that, that's where this kind of, you need to think about these kind of data modeling things. Cool. Yes, really good. It's a really good link, Fernando. So SQL BI do some really good free courses. These are all free. So Introduction to DAX is free. Introduction to Data Modeling is free. Really good ways to get started with DAX and data modeling, and it will go through a lot of the stuff I've talked about today in probably a much better way. Say today was covered an hour or just over an hour. quite a lot of content. So hopefully it's a bit of everything there, though. Great. Any other final questions? Thank you, Paul.
I think that's it.
Great. In that case, I'll just take 2 minutes just to summarize what we've kind of covered today. So the first thing is, to try to not be all things to all people. And I think that's one of the things we saw from the Menti questionnaire, that actually sometimes that's, reports that we build, we don't necessarily get the adoption that we want. And that's probably because they don't necessarily cater to a specific audience with specific problem statements and specific questions. So let's try and identify those up front, because then we really know what this report is trying to do. And sometimes we might say, actually, we need multiple reports, or it's not going to be one thing that can answer these different levels of detail, because maybe the exec audience needs a different level of detail to the people on the ground. And that's absolutely fine, but you won't know that until you've figured out the audience for it. So then look at defining the metrics that will answer those questions. So once you've got the business questions, what metrics will answer those? And you can define those in more detail. So you can go and define the definition, define the kind of formula you need for it, define the data owner for those. And you can use the metrics tracking template for those. And then design your data model. So really design how you want your end tables to look. So you're going to end up with dimension tables and fact tables, and that's the real structure you want for Power BI. So then it's just thinking about how you want to categorize your data. So look at what numerical data points you have by which dimensions. So that's why you can then use the bus matrix and the Starnets for really then designing those kind of relationships, if you like, just conceptual level. So before you even do anything with the data, that's just designing it. Again, you could do that completely as a non-technical exercise, but it becomes the blueprint for what you need to do in Power Query. And then once you've got your data model, really think about how to tell a story with the data. And actually the story with the data also comes back from the scoping template. So the scoping template drives two things. It drives the data model, because it drives how you need to design your data model, because you can look at that, you can look at these Starnets, or you could look at your data model design and say, will this data model allow me to answer these questions? That's what you want to be able to say. So you say, yep, I can answer the question about how many are delayed this month because I've got delay category on there and I've got the number of work packages delayed. So yep, I can see that I'll be able to do that. The second thing it allows you to do is go into storyboarding. So here's where then you can then say, okay, I know the questions I want to answer. How can I answer those questions, minimizing cognitive load? So, it's making it as easy as possible for the users to see exactly what that information they need is. So, how could I have a list of metrics maybe at the top that just tells people the core numbers they need to know? So if they spend within 3 seconds, they can look at this and say, yep, I know what the information is. I know actually I've got 5 work packages that have just become delayed that I now need to focus on. And then they can click on those and see exactly what those are, rather than having to make them work for it, make them dig for it. And look at things like color, interactions between visuals, and that user journey. One of the things you can always think about with the user journey is starting at a high level and then think about the 5 whys, which is kind of like it's a kind of technique that's come back from Lean about doing root cause analysis. And the example I've given before is like when you have a kid who continually asks why. So you've got, this is we've got a delay of this, or we've got a performance of this. Okay, why? What's the reason for that? Well, it's because in this month we didn't do as many. We didn't push as many work packages as we wanted through this stage. Why? Well, actually, it's because this is because the contractors haven't haven't engaged properly, or we can see that there's a common pattern amongst contractors. So really think about the user journey, the ability for them to go from that high level to give them the answers to what they need to know, to drill into why is that happening, what's the reason, and allow them to drill into that more detail. And that's what you need to think about with data visualization.